Right, welcome to this new video. We are solving tutorial questions. So I'm going to solve 3 questions from the tutorial. We have to solve non-homogeneous equation by using the variation of parameter, okay? Exclusively, we want to use the variation of parameter. And as I explained, the variation of parameter method, we have to follow all the steps that I've explained in the previous video. All right. For the first question, we want to solve the following differential equation by using the variations of parameter. So we know this means derivative, okay? Capital D means derivative. So if you multiply this through, you see that this equation is similar to second derivative minus first derivative is equal x times e to the power x plus 3x. All right, once you have this, and we have to find the homogeneous solution. And to do that, we have to first solve the homogeneous equation. So homogeneous equation, second derivative minus first derivative is equal 0. If you find then the auxiliary polynomial, what some people call the characteristic polynomial, so this is p of lambda, this is lambda squared minus lambda is equal 0. If you factorize this, we have lambda bracket lambda minus 1 is equal 0, okay? Then solving this, lambda is equal 0 or lambda is equal 1. Then we have these two solutions. Y1 is equal 1 and y2 is equal e to the power x, because we found the general solution as e to the power lambda x, okay? So in this case, lambda is 0, 0 here, e to the power 0 is 1, and the second y2 is e to the power lambda or 2. This is 1 times x. That's why we have this. All right. Once we have this, the homogeneous solution y0 is a plus b times e to the power x, with a and b in R. All right. This is what we have. Now let's move to the second step. The second step here consists of solving the particular solution. Then to obtain the particular solution, we let the general form of our particular solution, let's call it yp, is equal, we use this, okay? So we use u1 y1 plus u2 y2. The variations of parameter method says that, so using the variation of parameter involve identifying u1 and u2 such that u1 prime y1 plus u prime 2 y2 is equal 0, and u prime 1 y prime 1 plus u prime 2 y prime 2 is equal the left hand side of the equation here, this x times e to the power x plus 3x. All right, this is what we have. You have to know this formula. If you make a mistake, if you mess up and you confuse the derivative here, you get a wrong solution. So what you have to do is to know that this first equation, we don't have to prove it, of course, because in the previous video we have proven this, so there's no need for us to go through again, okay? So we have to solve this system. We want to solve for u1 and u2. First of all, we want to solve for u prime 1 and u prime 2, and after that we integrate to obtain u1 and u2. All right, the matrix forms of this is u1 here is 1, so this is 1, and the derivative is 0. The here is u2 is e to the power x, and the derivative is e to the power x. All these multiply u prime 1 and u prime 2. This is equal the left side, the right hand side, this is 0, x times e to the power x plus 3x. Right, we have different approaches here. You can use the Cramer's rule, or we can just find the determinants and multiply, as you know, as I explained in the previous video. But I can see that with this 0 here, it makes things very easy. If you, let's say, if you expand this again, if you multiply this, we obtain u prime 1 plus u prime 2 times e to the power x is equal 0. And the second one is 0 plus u prime 2 e to the power x is equal x times e to the power x plus 3x. All right, at this stage, I want to make it easy. I want to call this 1 and this equation 2. If here we say 1 minus 2, this is 1 minus 2, we obtain this is u prime 1 is equal minus x times e to the power x minus 3x. So if you integrate this equation, we have u1. So we do the integration by parts here. This is 1 minus x times e to the power x minus 3 over 2x squared plus c, constant c. For the second one, the second equation 2, we multiply the equation 2 by e to the power minus 2. So 2 give u prime 2 is equal x plus 3x times e to the power minus x. So if you integrate this, the first term is just 1 over 2x squared. The second one, we do the integration by part and obtain minus 3 times x plus 1 times e to the power minus x plus d, the constant d. All right, with these two, we know the general solution y is yp plus y0, particular solution plus non-homogeneous plus homogeneous solution. So this is, if we start with u1 multiply y1, so it just multiply by 1. This is 1 minus x times e to the power x minus 3 over 2 times x squared plus c. For the second one, we have to multiply by y2. This is 1 over 2 times x squared times e to the power x minus 3x plus 1 and plus d times e to the power x. And the last part now is this homogeneous solution. This is a plus b times e to the power x. All right, if here we consider constant, the first constant, this is a simple constant. Here is another constant, and the third one is this. If we call this constant alpha, we have alpha plus, for the second part, if we consider this, let's put this like this, and then so the terms, the constant carried by e to the power x, we consider this and we also consider this, then this is beta time, we call it beta times e to the power x. Then we remain with, if we start with this, minus 3 over 2 x squared. I'm done with this, minus 3 x n plus half of x squared minus x times e to the power x. So this is what we have. This is the solution. Of course, to obtain this, we set alpha equal, as you can see here, a plus c minus 1, and beta is b plus d minus 1. Okay, so alpha, beta are real. So this is what we obtain. So this is a general solution to this differential equation. So you can see that the first step consists of solving the homogeneous equation, and we obtain the solution, and we use the solution of the homogeneous equation to solve this non-homogeneous solution or the particular solution by using the variations of parameter. And at the end, we know that the total solution is just the sum of the particular solution and the homogeneous solution. We sum up these two and we obtain this. Okay, of course we did some simplification, and it's normal because if you have 2, 3 constant, you'll rather sum up the constant than having many constants in the equation. That's what we did here exactly. So this is all for this example. So I'm looking forward to seeing you in the next video for the second exercise.